There will be some proofs that when you use the standard strategy of changing to sine and cos and then getting a single fraction on both sides, they will still not be equal. This is a great example because everything's changed to sine and cos, both sides are a single fraction, and things are not equal. In these situations, there are two advanced strategies that you need to use. Either factoring, sometimes factoring will help you, but in this case, there is nothing that we can factor. And the other strategy is something that I call build the other side. I call it build the other side because you decide to make something the same on both sides by multiplying by 1. Usually it's a denominator, but sometimes it's a numerator. So right now, would you agree that my denominators are different? But if I wanted a common denominator on the left side and the right side, the left side is missing 1 plus cos theta. So I'm going to multiply the top and bottom by 1 plus cos theta. The right side is missing sine theta. So I'm going to multiply top and bottom by sine theta. What that does is it changes, and I'm not even going to multiply it out, I'm going to leave it factored, my bottom on this side to sine theta times 1 plus cos theta, and my denominator on this side to sine theta times 1 plus cos theta. And maybe, at least, if my denominators are the same, maybe there's something I can do in my numerators. So first of all, on the left side, what happens when you multiply 1 plus cos theta times 1 minus cos theta? Those are conjugates of each other. And when you have conjugates and multiply them together, you get a difference of squares. So 1 plus cos theta times 1 minus cos theta, if you FOIL that all out and simplify, you get 1 minus cos squared theta. And on the right side, sine times sine becomes sine squared theta. It's close. Can you get with sine squared plus cos squared equals 1? Can you rearrange things to get 1 minus cos squared all by itself on one side? What would it equal? 1 minus cos squared would equal sine squared. So you can do that as your next step. You could have also changed the other side to 1 minus cos squared. I call this strategy build the other side because I find students find that easy to remember. This strategy is often called multiply by the conjugate, but because the word conjugate is hard to remember, some people can't remember the strategy. So the build the other side strategy says, if I can get something the same, either numerators or denominators, then maybe the rest will work out for me. And in this case, after I changed my denominators to be the same, then looking at my numerators, there was something I could do. Yes?
Sorry, how did you get sine squared?
So we have, on our formula sheet, you have sine squared theta plus cos squared theta equals 1, right? Can you rearrange that to get 1 minus cos squared on one side? Yes. What would be on the other side? Sine squared. So again, even though 1 minus cos squared equals sine squared is not on your formula sheet, because it's a simple mental math thing to do to move something to the other side, you're allowed to do that in one step. The rule of thumb is that if you have to do like 2 or more mental math things in your head, then you should show them. But if you only have to do one mental math thing from a formula, you wouldn't have to show it. Does that make sense? Yeah, so what would be a bad mental math thing to do here is go this and then just write the answer and say I'm done. Okay, and people do that all the time. I'm really stuck on this proof. Maybe I'll just scribble a bunch of stuff and then write the right answer in the end. Okay? That, on the exam, the way the exam is marked right now, that's usually like a 2-mark deduction. Just like trying to smudge it and then write out what it should be in the end. Because usually you've made one mistake to get into a problem that you can't get out of. And then just by writing the right answer, you actually make another mistake. And so they deduct you for both of them. Yes. If you left it blank, if you just stopped and said, I can't do it, you might get 2 out of 3. If you make it up to make it look like it's done, you lose another mark.
If you didn't know how to do it at all, so you just wrote the answer, would you get any marks?
No.
Down.
If you don't know how to do it, how are you getting the answer other than looking at someone else's thing?
Okay. So what we're going to do now is we are going to turn to page 620. 620 is a blank page with nothing on it. And we are going to summarize the strategies that we have done so far. Okay? And I'm going to number these strategies. Yeah. Number 1. That's the main strategy we used at the beginning. Change things to sine and cosine and get a common denominator. That was the first thing that we came up with. Today, I'll label this number 2. We were introduced to the Pythagorean identities. So look for them. If you have sine squared, cos squared, tan squared, cotangent squared, cosecant squared, secant squared, it may be that one of those is a shortcut to doing things quicker. With number 2, okay, I'll put this as number 2. If you see a 1 in a question, that might mean you need to use a Pythagorean identity because sine squared plus cos squared equals 1. And I'm going to put always being aware of your goal, what the other side is, as something you always look at, whether using Pythagorean identities or changing things to sine and cosine. My numbering system is just sort of where did we come up with these strategies. Number 1 were the first strategies we found. Number 2 is sort of the second set of strategies that we ran into. And then the last one, which we did build the other side, I said sometimes this is called multiply by the conjugate, or that difference of squares one where we factor. Those are more complicated ones. So just write those down, and then we'll go to some harder proofs. Okay, once you've written those down, take out that identity sheet, and for the rest of the class, we are proving